Hello, today we're going to solve this quick integral. So maybe we'll start by using the King's rule, but I'm going to include steps for those of you who don't really know it yet. So what we're going to do is x is going to equal pi minus u. This also means if we just move some things around, u is equal to pi minus x. Now also, if we were to look at dx, that would just be equal to minus du, since the derivative of a constant is just 0. So now we're all set up to convert this integral into a u integral. So first of all, let's just look at this expression for the bounds. So first of all, if we plug in x equals 0, we have pi. If we plug in x equals pi, we have 0 up there. And then also we have cosine of pi minus u plus cosine of pi minus u du, but of course we do have to put a minus sign in front. Now we can use that minus sign immediately to switch the bounds of integration, and we're going to get 0 to pi. And what's nice about the King's rule is that, of course, these bounds of integration actually just stay the same. Now let's see what we've actually done to our integrand. Right? First of all, we're going to use a really important rule for this integral from trigonometry, which is that cosine of pi minus u is equal to minus cosine of u. So think about why that's true for a minute. Maybe do it visually. That really helps for most people. Basically, if we were to have a circle and we would have an angle u, and we would also have an angle pi minus u, so in the other direction, we have that the x-coordinate is the negative version of what it would normally be with just cosine of u. So that's just a quick sketch of why that's true. So let's utilize that, and we're going to get the integral from 0 to pi of cosine of pi minus u minus cosine of u. But maybe let's rewrite that quickly, and we're going to take these minus signs and we're going to factor them out. So we're going to get this expression. At this point, we can actually apply the same rule as before, where instead of u, we actually just have a function of u. So again, we have cosine of pi minus something that would be equal to minus cosine of that. So we would get the integral, or the negative integral, from 0 to pi of cosine of u plus cosine of u du. And now we'll just do a dummy substitution for x equals u, and we're just going to have x plus cosine of x dx. And what's nice about this is, if we were to call this integral here I, well, this integral over here is just the exact same thing. So basically we get I is equal to minus I, and there's only one solution to that, which is I is equal to 0. Let me show you that quickly. So I is equal to minus I. Of course, this means that 2i is equal to 0, and if we were to divide by 2, we have I is equal to 0. So our integral from 0 to pi of cosine of x plus cosine of x dx is equal to 0. So thank you so much for watching. I hope you enjoyed. Till next time.